Good afternoon, folks. So last night I started my post about the tides and the moon, and I said I'm in between. It doesn't matter what anybody else says, and I was in between that and a slam dunk, and I didn't slam dunk it. By the end of it, at the end of the half hour, the reel I did, I slam dunked it. I slam dunked it. Now, stepping on toes. I can't put too much of this on because all of my stuff gets the copyright check. And if I put too much of anything else on, I know they'll just stop the post. So see if you can guess what this is.
These are just going to be cartoons, and they're definitely not to scale. So
Right, okay. Was that math and science? Definitely cartoons, they're definitely not to scale. We're talking about the moon and planet Earth. Talking about the tides. It could be fairly important to have these things to scale. I always have things to scale. Otherwise, it's lost in translation. Now, I say it's common sense. It's giving me the poo-poos, right? I can't listen to this stuff. I can't remember everything that he said about why, how, yada, yada, yada. First up, yesterday, I showed you guys the 5 centimeter Earth, 1.4 centimeter moon, with 150 centimeters in between the two, perfectly to scale. Today, centimeter diameter Earth. There are 30 of those in between Earth and the moon. 3 meters. Boom, boom. It's 9 meters. It's extremely important to get things to scale. How can you explain something like this when things are not to scale? This is to scale. We have a 30 centimeter diameter Earth, an 8.3 centimeter diameter moon. The distance between Earth and this moon are 30 Earth diameters. This is perfectly to scale with that planet Earth. Now look. It's to scale. Distance. Common sense. You cannot explain something like this with gravitational forces if things are not to scale. They have to be to scale. It's all about that, isn't it? It's gravity. You need things to be to scale. See, I've got attitude today because, now, what we have is a 30 centimeter planet Earth. 30 centimeters in diameter. Over there, we have a moon. Now look. Now, that is the distance that the moon is from us, okay? It's to scale. It doesn't matter how big you go. It isn't a case of, oh yeah, but when the moon's bigger, the gravitational pull. The distance, everything increases proportionally the same as the sun and planet Earth. 8 minutes and 20 seconds. Let's not do that right now. With a diameter of 3,474 kilometers, the moon, the planet Earth, with a diameter of 12,742 kilometers, and the two of them are on average 384,000 kilometers apart. Is it logical? Screw the science right now. This isn't about the science. This is about the common sense that comes before the science. Is it logical to think that this would pull on the tides on that planet over there if it was spinning anti-clockwise? It's a very straight, easy question. Do you think that this distance away from that planet is going to pull on the oceans? Why is it not pulling on all of the other bodies of water, the enclosed system, the lakes, the seas? They say because molecules move and there's no room to move in the smaller bodies of water. What a load of rubbish. You're telling me that we can get a, how big is it? 30, nearly 40-foot tide created by that moon, but it's not going to shift one of the enclosed water bodies. It doesn't. They say that it does, but it's just too small to detect. With the naked eye, you need special instruments. Does that sound familiar to you? Now, the next thing. The moon, the position that it's at when we are spinning anti-clockwise on our axis, right? Do they or do they not say it's about the equator? So most of the pull from that moon would be here along the equator as we spin anti-clockwise. We spin, they say, that planet Earth moves into a bulge, don't they? What a load of rubbish. That isn't possible. Look at that landmasses. That's the equator. That is where the bulge would be. So what they're saying is planet Earth, as it spins, there's a bulge here because of that moon. That's 30 diameters of this away from here. Now, as it turned, the tides, the biggest tides you would expect to see is common sense, okay, is here because it's about the equator. That's where the moon is, over there. We spin, right? It's the equator. That is in line with the moon. Northern hemisphere, southern. So if there was a bulge, this is where you would get the crazy tides, right? When you come over to the US, I mean, the tides here, right? This is where you would get the tides that you're getting up here because the moon is there. It's not pulling on anything up here. Listen, this is how common sense works. It doesn't matter what science says. Now, the bodies of water. This, it's where it gets insane, right? The moon is by the equator. Because of our elliptic orbit and the moon's elliptic, the way it works, looking at the moon, it kind of, in the sky, it goes from the northern hemisphere to the southern. Because of the way we spin, because of the way the moon is moving, right? It stays roughly by the equator. Now, vámonos dentro. See, this is why they don't like me. This is why they don't like my stuff. Now, the highest 5 tides on this planet are in the Bay of Fundy in Nova Scotia, Ungava Bay in Quebec, Bristol Channel in the UK, the Cook Inlet in Alaska, and Rio Gallegos in Argentina. Now, those places are all up at the north. Nova Scotia, Quebec, that Ungava Bay, okay? Right? Anybody who knows geography, the next one along, this is the 4th highest tide though, not the 3rd. That's Alaska, right? How far north is Alaska? The Cook Inlet. We keep going, we're still north. The Bristol Channel in the UK, right? The Bristol Channel. Here's the British Channel, and just above it, there's another channel that goes in, but it's in England, like it's part of England. That is the 3rd highest tide on this planet. So all of a sudden, you're told that there is a bulge. The moon is creating a bulge in the water, okay? But this is the equator. This right here is the line where the bulge should be, where most of the tidal forces should be, because it's the moon and it's attracting the water. Why is it that the tides are not special down at the equator where they should be if it was the moon? Why are you seeing these massive tides all up north, apart from one, which is down in Argentina? That is the 5th highest tide on this planet. Now that could become key, right? Now, this is looking down onto, as if we're looking down onto a flat earth. That is the North Pole, the Arctic, right? That is bang in the middle. Now, Bristol, that's there, right? So when you're looking down, you see it there. Bristol. Go over to Nova Scotia, Nova Scotia, which is there. And then we have Ungava Bay, which is there. Oh, sorry, there. And then we have Alaska, the Cook Inlet, which is there. Let's just let Argentina chill for now, right? Why is it that the moon is pulling down by the equator? That's where it's at. But when we look at the crater, we are talking some serious tides here. There are 4 up here. Highly illogical. It defies common sense and it defies logic. This is why my stuff is, shadow banned, right? Now, this isn't the only thing. If planet Earth was moving into this bulge that they say, right? And the tides, the planet Earth was moving into them. We spin anti-clockwise on our axis, right? So we are spinning like this. The moon's pull is here. This is the equator. It's 30 Earth diameters away from us, but that is the equator line. That is the moon. Northern hemisphere, southern hemisphere. Is it logical to think that as planet Earth is turning, if it was turning, go away fly, into the bulge, what we have is the Bristol Channel, right? Now the Bristol Channel, it's facing that way out, right? That way. We are moving that way. All of the tidal water, if there was a bulge, would be bulged up here and we move into it. How does that explain water flowing into the Bristol Channel? If we were spinning that way into it, yes, but we're not. We're spinning away from the bulge that doesn't exist anyway. But what I am saying, it's their facts. It's their facts. They're coming up with this stuff. And just common sense, bang, it does not make any sense. It doesn't, right? Bodies of water. Bodies of water. They're too small. They're too small. Do you know how big some of these lakes are? This is Africa. You've got these Black Sea. Listen, when I say it's an insult to your intelligence, it is. If you think that the moon is going to pull the water on this planet, right, up to 38 feet, that's 11, nearly 12 meters in these big tidal areas, you're telling me there's Nova Scotia, right? What's this? You have lakes right up north in between the biggest pools, the biggest tides, not pools, the biggest tides on this entire planet. And you're going to tell me that in lakes that are hundreds, some, I believe, if not over 1,000 kilometers long, definitely hundreds, and deep, you're telling me this is the bit where things are falling apart, because that is pure common sense. It's like, it's so illogical, right? On one hand, it's dragging the bulge, but not the smaller bodies of water. No bulge there, folks. Listen, it is not logical to think that the moon has anything to do with the tides. Number one, the distance between the two and the size. All right? The distance between the two and the size. .3 centimeters. That is perfectly to scale with a 30 centimeter diameter planet Earth. How do you do it? We're 3.6 times bigger than the moon. 12,742 divided by 3,474. I've got a 30 centimeter diameter Earth. All I do is divide it by 3.6 and I get the diameter of the moon. It's all to scale. We know 384,000 kilometers is the average distance between Earth and the moon. Earth's diameter. One division exercise later, we have 30 diameters. This, folks, is perfectly to scale with the moon size, the planet Earth size, and the distance in between. Right here, it's 9 meters. In real life, it's 384,000 kilometers. Now, I will say it again. Don't forget what you're seeing here is perfectly to scale. If you were a giant or you were a god, or you'd seen things from my perspective, this is how you would see them. Right? Now, I'm asking you, it's not what science says. What do you think? Do you think this has the power, the gravitational pull, to create some bulge on that planet over there, but not touch the other water bodies because they're too small? It is an insult to your intelligence. They are not small. Right. Now, it's not about what science says. I am showing you the correct scale of what is being, not what is being claimed. These are the numbers they give us. Right. So now you have yourself. He starts off saying, well, they're not to scale. Of course they're not to scale, mate. Not convenient, is it? I look, somebody's got to say something, right? For me, it's common sense. This is about common sense. Now, what you've got behind us on this board right now, it is a work in progress. What I have, it's not finished yet. I thought doing a couple of days was going to give me a pattern. What I'm doing, finding out a certain time when it's a high tide in the Bristol Channel, and at that very same time, local time everywhere, in real time, so different time zones. Find out exactly what the tide is doing in the Cook Inlet, what it's doing in the Bay of Fundy, what it's doing in Ungava Bay, and Los Gallegos in Argentina, because it's strange. This is all strange. I'm not saying I know what creates this tidal rushing of the water, but the moon, folks. I've slam dunked it now, right? I have. I've thought about it enough. I've heard these things enough, and it's just a big insult to people's intelligence, but you don't know. You do not know that, right? I don't care what they say. It is my job to do what I'm doing. You might not like it, but your children might appreciate it one day, okay? Let's forget Argentina. The four biggest tides, the highest tides. Nova Scotia, the one on the right. You don't have to worry about the 2147, that was something else, right? A tide of 38.4 feet. That's 11.7 meters. Ungava Bay in Quebec, right? A tide of 32 feet, 9.8 meters. The Cook Inlet, a tide of 30.3 feet, 9.2 meters. We're going to stay nice and northerly, and when we get to Bristol in the UK, Bristol Channel, 31.5 feet. That's 9.6 meters, right? I'll say it again. Why? Why are the highest tides on this planet up north? Why? It's the equator. If the moon is as they say it is, right, we're tilted the wrong way there. It would be not straight out in front of us, it would be slightly up, because this is how the system works. We spin that way. The moon is focused mainly, its gravitational pull should be here, right? should be here. This is where the crazy tide should be, because Earth is moving into the bulge. Earth doesn't move into any bulge, it's illogical. It's highly illogical. You can't have a bulge here. If it was moving into a bulge, it would be like a tsunami going over the islands, wouldn't it? You've seen the tides up here. These tides were running here, it'd be a nightmare along the equator. But funnily enough, pretty mellow, isn't it, the equator, tide-wise? Highly illogical. It defies both common sense and logic. Don't underestimate common sense, folks. This isn't about science. This is about listening to what they say, seeing what we've got, and trashing it. And in more than one way. You think I'm here to be difficult? I'm not here to be difficult. I see these things and hear these things, and it's a disgrace, right? That's why I'm doing what I'm doing. All right, calm down now. Calm down, calm down. Right, now, this is a pattern that I haven't finished with, right? It's not like, I don't think a pattern is needed. But what it will show, if I can get enough numbers down there without my head going boom, because I don't use AI, I like to grind it out properly. That's how you learn. Never use AI for something like this. You need to get the numbers in front of you, doesn't matter what it is, and work through them manually. Only then do you know that it's right. You cannot trust anybody else's stuff because they don't put things to scale. That's why I trust my own judgment on things, and I'm objective, okay? Ah! Oh! Mamma mia! There's a screw on there, okay? I just stepped on it. If you find out what each tide is doing at that particular time, but when one is at high tide, what are the others doing? When one is at low tide, what are the others doing? There will be a pattern. There will be a pattern. It will show where the water's, what's happening, won't it? It's about getting enough tide numbers, right, to get a pattern. Now, I thought 2 days was enough. So I'm going to have to go a little bit harder. It is something that I am going to work on because it interests me. I want to know. I want to know what pattern comes out. There will be a pattern. And it's not going to have anything in common with the moon tugging at planet Earth's water, but leaving the smaller bodies of water alone. That is highly illogical. It's highly illogical. If it can pull at the oceans the way it does, I think it could pull a little bit more at the Mediterranean Sea. It does a little bit because of the Straits of Gibraltar. I'm talking about lakes all over the planet. Big lakes, hundreds, if not thousands of kilometers, right? No, it's a lie. If it can pull the oceans, it can pull some of the smaller bodies of water. That is a slam dunk. It's ridiculous to say otherwise. This is the common sense thing. Do people not, when you hear that, what do you think? Do you think, no, it won't affect the smaller bodies of water? Because that's what you've been told. But it would. It would. Thousands of kilometers. You can tell me that it would. No, it happens, but you need some kind of super duper quantum technology just to measure it. It's that tiny. Really. That tiny, huh? All right, look, coming up to half an hour. I'm going to leave that there. Slam dunk. No. There's too many basic common sense reasons. Why not? It's not about the science, folks. Once again, it's not about the science. Later.